All right, so these notes are about reflections. Now, this worksheet you didn't get in class today, but you will get in class tomorrow. So what I expect you to do is on a notebook piece of paper is write down everything that I'm going to use to fill in the blanks. So tomorrow when you get this, you're able to quickly fill in the blanks. So a reflection is a transformation that flips a figure across a line of reflection. So we have a line of reflection that splits things up. Okay? Each reflected point is the same distance from the line of reflection as is the corresponding point on the pre-image. So wherever it starts, it's going to be the same distance away on the other side of that line of reflection. Okay? It's just going to be, but on the opposite side. So it's going to be the same distance away. It's just going to be on the opposite side of the line. Okay? So that means that the resulting image and the pre-image are mirror images of each other. So it's like the line of reflection becomes just a mirror that you're seeing on the other side. Okay? So using this graph below, the coordinates of A, B, and C. So the coordinates of A are negative 7, 5. The coordinates of B are negative 7, 2. The coordinates of C are negative 3, 2. All right? If you look over here, the coordinates of A prime, which are the A with the apostrophe, is 3, 5. B is 3, 2. And C is negative 1, 2. So what's the difference between them, or the distance between A and A prime? All right, so the distance between these two is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces apart. Okay? The distance between B and B prime are 10 spaces apart. C and C prime are only 2 spaces apart. Okay? So what would be the line of reflection in this case? So if you look here and you look straight down the middle, what is directly in between them? Okay? It's 5 spaces away from the A, 5 spaces away from the B, and both of these dots are 1 space away. So the line of reflection is going to be at x equals negative 2. Okay? So the line of reflection can be the x-axis, the y-axis, or it could be any other line in the coordinate plane. So the 3 most common lines of reflection that we're going to see are the x-axis, the y-axis, and the line y equals x. It doesn't have to be a vertical line or a horizontal line. It can be any line. Okay? So the following diagram shows a reflection across the x-axis. Okay? The ordered pairs of the pre-image are 2, 6, 2, 3, and 6, 3. The ordered pairs of the post-image, or the image itself, which A with the apostrophe is called A prime, are going to be 2, negative 6, 2, negative 3, and 6, negative 3. How are the values of x and y reflected? Well, the values of x aren't changed at all. X has no change. So x stays the same. Y changes the sign. So what's the distance between point C and the line of reflection? Well, from C to the line of reflection, that's 3 spaces. What about C prime? Well, it's also 3. They're going to be the same. The relationship is true, not exact distance, because A is obviously farther away, but the relationship's true. A prime is the same distance away from the x-axis as A is. So this distance is true both times. All right? So when a point or a figure is reflected across the x-axis, Okay, the sign of its y-coordinate changes. Nothing else about it changes, just the sign. All right, so the function is the function for reflection across the x-axis, and so you got to be able to write it in function form, is your reflection across the x-axis. That's how you notate the function. All right, takes x and y and changes it to x and negative y. It changes the sign of y. All right, so now we're going to do one across the y-axis. So we're going to start with the ordered pair of A, B, and C. 3, 7, 3, 4, and 7, 4. The ordered pairs of my prime over here are going to be the opposite signs, not of the y this time, but of the x. All right, so x's sign change, x changes sign, y stays the same. All right, the distance between them, so C and to the y-axis on both sides are 7 apart, and yes, the relationship is the same. Okay, so when a point or a figure is reflected across the y-axis, the sign of x changes. So the function for reflection across the y-axis is a reflection over y-axis, where the points x and y are negative x, y. So it's just changing the sign of x. We're going to stop there for now. We'll finish this one in class.